Hi everyone. Today we are going to talk about the module 2, that is a serviceability and durability of the concrete. The module 2, we are going to discuss the importance of the serviceability and the durability of the concrete structure, quality assurance and cracking and the environmental effects on the concrete structure. So these are the topics we are going to cover in the module 2. So, quick recap of the module 1, what we had discussed in the earlier, that is the maintenance and repair strategies. So, here the basic fundamental definition already discussed what is in the maintenance, repair and rehabilitation of the structure, and followed by the importance of the maintenance and effects of the maintenance and inspection of the various concrete structures and various assessment procedure for involved to assess the existing concrete surface and what is the causes of the deterioration of the structure, how we are going to prevent those type of the deterioration of the concrete structures. So everything we are discussed in the module 1. Now we are going to discuss about the module 2, that is means serviceability and durability of the concrete. So here, so elaborately, we are going to discuss about the quality assurance of the concrete. So quality assurance, we can able to maintain the before concreting and during concreting and after concreting. So three stages are important to maintain the quality of the concrete. And after that, we are going to discuss about the strength and durability of the concrete and how the formation of the crack and how we are going to repair the various type of the cracks. Finally, we are going to discuss about the effect of the climate and the temperature on the concrete that we are going to discuss about the detail in the module 2. What is our module 2 objective? The first prime objective of the module 2, learner to understand the serviceability and durability of the concrete structures. How the serviceability, it indicate that comfort of the people and safety of the people and proper functioning of the concrete structures. The durability indicates that long life of the structure and resistance to the damage of the structure. So how to prevent the serviceability and the durability? So we need to maintain proper maintenance. That is means no excess of the cracks and deflection and water leakages. While talking about the durability, we can able to achieve resistance to the weather and moisture and chemicals. So these are the coming under the objective 1 for the module 2. So objective 2 of this module 2, learners should apply the quality of the practice to achieving the concrete strength and durability of the concrete. How we are going to achieve the quality of the concrete? So we need to maintain these 3 stages: pre-construction stages, during the construction stages, and post-construction stages. We need to proper quality of the proper standard procedure we need to maintain to achieve the quality of the assurance. For example, we need to maintain the proper quality of the mixed design. We need to select the quality of the high quality of the materials. So here the material indicates that for making the concrete, it's the cement, one of the prime materials and binding materials, fine aggregate, is coarse aggregate. If you want adding the admixtures, those are the materials we need to select the proper quality of the materials to achieve the quality assurance of the concrete. Then concrete placement and consolidation and appropriate the curing methods we need to follow. So we need to, that is a sequence procedure should be followed as per the Indian standard to achieve the quality assurance of the concrete surface. The third module 2 objective is learner to study the different type of the cracks in the concrete surfaces and what is the causes of the concrete surfaces. Okay, so here we are divided into 2 types of the cracks. One is the structural and material causes, and second one the environmental and exposure effects. In the structural and material causes, plastic shrinkage cracks and settlement cracks may be followed. Because of the foundation failure, settlement cracks also will come. Okay, so environmental exposure effect, a temperature variation, maybe temperature increases or decreases, the vice versa. So definitely some cracks will be occur in the concrete surfaces. Okay, then movement of the moisture. So these are the reason definitely some cracks will be occur in the concrete surfaces. Finally, the module 2 objective, the learner should analyze the effects of the climate and the temperature on the concrete behaviors. So here are two key points. One is the environmental and moisture effects, and second one heat and drying effects. So freezing and thawing damages, definitely the behavior of the concrete will be changes. Then moisture penetration, maybe gases or liquid water, maybe through cracks it will penetrate in the concrete surfaces. Definitely it changes behavior of the concrete will be changes. That is also we are going to discuss in the future slides. So because of the heat, okay, heat reduced and increasing the cracking may be chances, and rapid moisture losses, that's the shrinkage crackers. So these are the things, definitely the concrete behavior going to change. That's why we having weightages giving by the both sides the adverse weather effects and affects the strength and the durability. So these are the objectives of module 2. We are going to elaborate and discuss in the future slides. So finally, the main crush of the module 2 helps the learners to understand the importance of the serviceability, durability, and quality assurance of the concrete. After that, then crack behavior, the formation of the crack, and the environmental effects on the concrete structures. We are going to discuss over the module 2. So first topic is the quality assurance of the concrete. The quality assurance to achieve it is systematic the process. What is systematic the process? To achieve the quality of the concrete, we need to maintain the pre-concreting, during concreting, and post-concreting. These three systematic process we need to maintain from the starting onwards. Selection of the material. That's why we are discussing earlier in objectives that we need to select the good quality of the materials and workmanship, the people who are working in the concrete stages, and the construction meet the required standards. Okay, so this quality assurance will be involving the various testing. Testing means what is that? Here, when you're going to make the concrete, we are going to use a different type of the materials, which are fine aggregate and coarse aggregate and cement. Everything we need test properly. Some of the example we have shown in the picture is some cone is a test is very important for the concrete, and cube testing is also important for the concrete section. Okay, then various inspection during the concrete process and monitoring during the production and mixing, placement, and curing. These are the involves in the during the concrete processes to maintain the quality assurance of the concrete. So when you are looking the sequence, what is that? We need to do the proper material inspection. So all the coarse aggregate and fine aggregate, cement. Sometimes we are going to mix it for admixtures also. That is also we need to proper inspection. Okay. So mixed proportion verification. Yes, our concrete structure we are going to make as M20 concrete or M30 concrete. So that everything mixed proportion, cement, fine aggregate and coarse aggregate, everything we need to proper verification. We need to see. Then batching control. This is all everything for the pre-construction stages. When you're putting the concrete, we need to check the proper reinforcement, main reinforcement, distribution reinforcement, torsion reinforcement, maybe column or beam, a slab, whatever maybe the structure we need to follow during the construction for the checking of the reinforcement. Then supervising the placement of the concrete structure. Once the concrete is mixed, we are pouring to the concrete. That is also we need to mix. So before going to pouring concrete, that way we are going to conduct the test. That is one of the tests is for exclusively for the slump code test where we need to applicable. Once the during construction stages is over, then we are going to for post construction stages. Okay, that is for exclusive for curing. Then after construction, some of the crack will become okay. That is shrinkage cracks. Okay, other temperature variation of the crackers, everything will be occur. So everything we need to monitor. What is the final aim, our ultimate aim? We need to monitor, we need to systematic process, we need to follow to achieve the quality, the assurance of the concrete structure. Once if you are maintaining the pre-concreting, during concreting and post-concreting, we will get the guarantee required strength, what we are aiming, what we are dreaming, the required strength. Okay, what is the durability and performance, everything we can able to achieve once if you are maintaining the proper quality assurance of our concrete surfaces. Okay, so this is the sequence of methods we do following for the quality assurance of the concrete. So what is the three stages? One is for pre-construction stages, and second one for the during construction stages, and third one for post-construction stages. Okay. First, pre-construction stage to ensure high quality of the material and proper mix design we need to follow to maintain the quality of the assurance of the concrete. When you are selecting the material, aggregate or fine aggregate or coarse aggregate or admixtures or cement, whatever may be, quality we need should not be compromised as a civil engineer. We need to select the proper high quality of the material for our concrete. Okay, whatever may be the mix design, when you are doing a trial mixes, okay, we need to follow the correct methodology for whatever may be the M30 concrete or 40 or 45 maybe the concrete. So before going to the start, we need to test all the materials. Okay, aggregate testing will be there, flakiness test will be there, impact testing will be there, abrasion test will be there, elongation test will be there. Okay, these are the aggregate will be C1 analysis. Okay, all these tests we need to calculate. Then when coming to the cement, we need to initial setting and final setting, finest, modulus and roundness, everything we need to testing before coming to the. So whatever the mix design will coming based on the, we need to follow the trial mix assessment based on the workability and strength. So we need to monitor the proper water cement ratio control and mix proportioning and adjustment and lab testing analysis for the trial mixes what we decided for the site, that everything we need to achieve in the lab results. So before going to the concrete, we need to assess, we need to give the assurance, we need to get the standard value. Okay, that is we need to maintain to achieve the quality assurance before concreting itself. While coming to the during construction, just where you are going to construct, we need to proper site inspection. How the climate will be there, how the construction site will be there, what is the pros and cons and workmanship, what is the floor constructions, okay, the soil behavior, okay, everything monitored properly for a workmanship. Okay. Then we need to conduct before going to slump test also. So slump test is a very, very important for the concreting purposes. Okay. So making and curing the test specimen we need to do. And concrete is the temperature monitoring. If we are going to do for the high temperature more than 50 or 60 degrees Celsius of the concrete surface, we need to predefine the proper for the temperature monitoring also. So rebar placement and alignment of the checks when your beam or beam column joints. So everything rebar checking we need to do proper. So field adjustment to mix when necessary. Yes, my site is different places. My RMC is different places. It's a more than 3 hours, 4 hour traveling time is to be required. When your traveling time is to be required, automatically some water cement ratio maybe water will be evaporated. So for that also, when you're pouring in the construction site, we need to evaluate it properly. So some field adjustments we can able to modify for our mix designs also. Okay. So before the concrete, everything test we need to conduct for the cylinder molds or cube or strength, everything we need to conduct properly for stages. Okay. So proper curing methods and duration, everything we need to monitor properly. So main only IMF during construction is to monitor and manage the concrete placement and compaction and curing. Okay, everything we need to monitor for the during construction stages. What is the post-construction stages? We need to, after concreting is over, what will happen immediately? What will some of the amount of the water started to evaporation? Okay, so maybe the shrinkage crack will be occur. Okay, that we need to identify the proper through the inspection, the crack inspection. So after harden the concrete, we having a method for NDT, non-destructive testing methods, rebound hammer method for the surface hardness test. What we did for the proper mixed design, what we did for M30 or 40. Okay, so for that whether we are achieved or we can able to identify through for the rebound hammer test. So once the test also will be conducted, then we can able to test for the permeability test. Okay, so whether concrete having a permeability or sometimes what will happen, we are not properly doing for the form work. Definitely some of the cracks, some gaps will be there. From that, water can able to permeable. Okay, maybe example for chloride or water can able to penetrate. Once water is entered into through the concrete structure, definitely is going to meet into the reinforcement. Maybe it will be 100% chances for the reinforcement corrosion. So maybe core extraction and testing also may be possible. So evaluation of the composition through the core sample. So we can able to take the sum of the sample. Okay, that sample we can able to test for the compressive strength to identify to assess the concrete structure. This is for the destructive techniques. So for assessing the concrete, we having a chances of two methods. One is for NDT and non-NDT structures to assess the existing concrete surface. Then finally, analysis of the concrete, the permeability and carbonation depth also we can able to discuss. So these three stages, what is our aim? These three stages we need to maintain the proper quality. Once we maintain it, we can able to give the assurance of the quality of assurance. Okay, so this means identify and address issue, ensure the safety and durability. Yes, I'm going to construct the new home. I'm going to buy a new home. What is our ultimate? I need to make it a safety. Then what is a building that we need to take over the more lifelong period, more than 50 years or 8 years, that durability. So everything should be based on the what we are doing in the quality. Okay. So as a civil engineer, we should not compromise our quality of the concrete structures. So this is a topic is important for our concrete structure. So this is a topic. Next topic, strength and durability of the concrete. So its indication. What we are going to for strength of concrete? The concretes. Okay, our concrete member, our building member. What is the main prime aim is to resist the forces. Maybe it's a dead load, maybe it's a live load, it's maybe a lateral load, whatever it is load. Our concrete structure to resist without breaking and without deforming. Okay, that is called strength. So is the main big strength of the concrete be focused on the concrete, it be ability to withstand the load and stresses. So how we are going to find out the strength of the concrete based on the compressive test, tensile strength and flexural strength. So these are the key tests are available to maintain the check the strength of the concrete. So these three tests are they having different factors are influencing. One is for a water cement ratio. When your water is added, the vocabulary is increasing, automatically strength will be reduced. It's vice versa. Then curing time. If you're having good curing, you'll get the more strength and durability will be increasing. If you are not properly curing, whatever strength will be reduced, durability also will be decreases. Okay. Then admixes. Okay. These are the things, few things are the for factors influencing you for the strength of the concrete. Okay. Then coming to the durability, as our member, as a building, as a structure, concrete will resist the deterioration. They want so many forces or so many causes. Our building should not the deterioration and maintain the desired properties over time. When you are going to start the construction, work, I have a desired the properties of the concrete. Okay, that properties you need to maintain the whole lifespan of the structure. Okay, that talks about the durability of the concrete. So main key focus on the durability of the concrete. Our concrete member is ability to withstand all the environmental climate, hot climate, cold climate, remaining wind and rainy season, environmental effects, chemicals, all the everything to our building can be withstand. Okay, that is talk about the durability of the concrete. How to measure this durability of concrete? One is about permeability test we can able to conduct, then chemical resistance, abrasion, and freezing thawing resistance. So these are the testers can able to measure the durability of the concrete. So here also the factors are influencing the permeability. Yes, high permeability water can able to penetrate, automatically durability will be decreases. So what we need to do, we need to make our building as an impermeable one. Then curing method is one of the prime. The curing is important. That is also one of the factors influencing durability of the concrete. Then cover of the reinforcement. Okay, so we know as per IS standard, we mentioned the cover of the slab, cover of the beam, cover of the column, cover of the foundation. That we need to follow properly. If what will happen if not maintained, maybe chances the water can able to moisture can able to penetrate into the concrete surfaces. Then it will corrosion will form the bars. Definitely durability will be decreases. Okay, then admixes. Okay, so these are the factors will be. So these are the pictures. So what you do even permeability test we can able to do, and chemical test and freezing thawing resistance, everything we can able to measure the our durability of the concrete. So first we are going to discover the key point of the strength properties. So strength we are going to achieve the three methods. One is a compression testing method and is a tensile strength. So normally concrete is very good in compression, very weak in tension, but directly we cannot able to measure the tension and such. That's why we are going to do for the split cylinder test. Okay, direct tension is quite is possible. It's quite a bit difficult. That's why we are doing for making the cylinder and using the UTM. We can able to conduct for a split cylinder test. And final for flexural strength. Okay, so first these are three methods are available to assess the strength of the concrete structures. So compressive strength. Normally, for compressive strength to achieve the concrete surface, we can able to use for a cube and a cylinder. So the cube cylinder is a minimum for 100 mm and 150 mm should be standard size. The cylinder for the 300 mm diameter we using for the cylinder to make it the strength of the concrete. Okay, when you're selecting the specimen, what we need to make a desired trial mixes. Maybe it's M15 or M50, M20 concrete, whatever may be the concrete, we need to select. For the selection of the concrete, we have started to pour in the three layers. Each and every layer we need to compact using the tampering rod. The minimum of 35 strokes. Okay, that we need to do the proper. Then only we can able to get the we can able to reduce the voids and the honeycombing formation. Everything we can able to reduce. Okay, so we need to properly compaction that we need to use. Once the concrete is in the over, after immediately next day we need to remove the mold. Then we need to keep it in the water tanks. Okay, tank specimen or in the water tank is be testing. Once a pour in the water specimen, we need to cure minimum of 7 days or 14 days and 28 days. So once it is over 7, 14 and 20 days, we need to take it from the curing tank. We need to keep it in the normal room temperature, just outside. The atmosphere will be spread out. Okay. So after that, we need to for UTM, universal testing machine, the compression testing machine we need to keep in the machine. Okay. Then started to apply the gradually load until the crack will be occur. Okay. The place the cube or cylinder in the compression testing machine. So once gradually applied load up until the failure. So note down the maximum load applied and record the compressive strength. Okay. So how to find out the compressive strength? Total load divided by cross section area. We can able to achieve the cross section area. Suppose I made up for the compressive made of the concrete M20 concrete. My compressive strength not less than 20 Newton per mm square. Okay, should come. Okay, that's be then otherwise I'm making for a trial mix of M30 concrete or M40 concrete. We need to follow the standard same procedure. They need to conduct the test. Our value should not less than the 30 Newton per square or 40 Newton per mm square. Then only we can able to achieve the proper composition. This is one of the prime method to assessing strength of the concrete for Cuban cylinders. Next, coming to the split tensile test. Earlier we told that concrete is very good in compression, very weak in the tension. Okay, no need to measure the for tension also, but concrete also it will take the little bit of the tension. So we having a two method to find out the tension. One is a direct method and indirect method. Direct method is not possible. It's quite uncomfortable. It's quite difficult to measure the tensile stress. Then we can able to follow the one more method is a split cylindrical test. So what we need to select the proper cylinder, standard size of the cylinder, minimum 15 mm diameter. Same like that, what we have followed by the compression testing. For that also we need to pour the concrete layer. We need to 35 stroke. We need to give the tampering rods. We need to compact it properly. Then we need to curing properly. They need to remove the mold and need to keep in the conch. Same like that, we need to 7 or 14 or 24 days we need to curing. After that, we need to 7 days or 14 days, we need to take the mold from out the specimen and then we need to keep in the room atmosphere. Then we need to keep in the test specimen in our compression testing machine. Testing is in the horizontal layer. Then we need to started to gradually apply load. The test we should focus on the split the cylinder into two halves. Okay, then only we can able to achieve the our proper indirect that is split tensile tension. So determine the tensile strength of the concrete. There is the 2P divided by L by D. 2 equal to what is the force we are applied and L equal to length of the cylinder and D equal to diameter. So using this formula, we can able to find out the split tensile strength of the given concrete. So third test is a flexural. It's like it's a beam. Beam is a flexural member. Concrete strength. Okay, as usual, we need to select for a specimen flexural test, the 150 by 150 mm by 700 mm, having a different specimen. Like that, what we have followed this test procedure, we need to make is a concrete. We need to compact properly using the three layers. We need to cure mainly for the 28 days. Normally, we need to keep. After that, what we need to keep in the comparison estimation. The testing method we need to changes. The support condition we changes. That means a 2-point loading. The place a beam in the machine under the symmetrical 2-point loading. Okay, then we need to keep the load gradually properly. Then we need to observe the where the cracks are forms. The cracks are from the bottom. That is a flexural crack. So it will be simply supported to mean when you're going to apply the load, definitely the crack will be occur in the bottom. Okay, that a flexural crack will be occur. Then it will subsequently be failure in the tops also. Okay, so this is a linely vertical. The crack will come. So using the modulus of rupture, M by Z is the section modulus, M is the moment, we can able to find it FR. So calculate the load at which concrete breaks and cracks will be formation. So this is called the flexural concrete strength. So using the three method, we can able to assess the strength of the concrete. One is a compression test, and tensile state, and the flexural concrete state. Using these three states, given concrete, we can able to assess the strength of the concrete. This is called for destructive techniques. Okay. So one more method is available, non-destructive. We should not break the materials. This NDT we are going to discuss about the later. How we are going to determine the strength of the concrete without deterioration, without breaking of the concrete structure. Well, coming to the durability of the concrete, so what is the definition, pure definition? Our member structure is the concrete to resist the deterioration and maintain the desired properties over a time. Okay, what I maintained, what I initially assumed the properties, okay, that we need to maintain the over period of the lifespan of the structure. Okay, that means ability to withstand the environmental. That means our concrete structure should withstand the all the environmental condition and is a chemical attacks. Okay, that is mainly focus on the durabilities. How to measure the durability? Based on the permeability test, based on the chemical resistance, based on the appraising test, based on the freezing time test. Okay, these are the tests available to measure the permeability of the concrete surfaces. So here also the many factors are influencing for our durability. Permeability, yes, of course, more permeable, durability will be decreases. Curing time also, if not properly curing, durability also decreases. Cover of reinforce, if not provide the proper cover for the reinforcement, durability decreases. If not used proper for admixtures for the requirement process, that is also durability will be decreases. So these are the factors. Some factors will be influencing for the durability of the concrete structures. The first important test, which is called the permeability test, permeable. Okay, so permeability to ability of the concrete to allow the water or gases to pass through it. So as a civil engineer, our ultimate aim, our concrete member should not allow the permeable. Okay, that is important. Somehow, what will happen? So it will be permeable. So automatically, water or gases passes to the that concrete member and with that. Okay, so what will happen is directly to affect the durability of the concrete. Yes, water started to penetrate inside the concrete surfaces. There may be definitely be chances of the corrosion of the in the bark. Okay, so what will happen? High permeability automatically lower durability. Less permeability is be higher durability, is vice versa. Okay, that is into corrosion. So corrosion of the reinforcement is be caused by the water and the chemical is be entering in the concrete. Of course, so our ultimate what will happen? We need to prevent the water penetration in the concrete surfaces. When the moisture or water or gases penetrate in the concrete surfaces, so automatically it is going to touch into moisture, going to touch in the rebar, which causes the corrosion. Okay, so some of the structure, no, it's like called as a lifeline structure, dam, nuclear power plant. So this structure is called for the lifeline structure. We should not compromise the quality of the concrete. That those type of the structures should be not permeable. It's an impermeable one. We should not allow the small hairline crackers also. Okay, what we are going to do, measure the permeability test for the given concrete. We having a test to proper procedure is with that. Then we need to keep in the test in the 5 to 6 specimen indicate. Then we need to give the proper pressure, okay, water pressure from the bottom of the places up to 72 hours. So continuous water pressure we need to give properly. So what will happen now? If having a permeable, if having our concrete member having a permeable, through that water can able to penetrate. Okay, so we need to observe the 72 hours. After that, what we need to clean the properly for the given specimen. Then we need to keep in the test. Okay, we need to break into the two pieces for the cylinder. So we need to observe how many depth penetration of the depth because of the pressure, water pressure, how much depth are passed to the this concrete surface. We can able to measure the permeability testers. Okay, the picture shows concrete surfaces. Some of the reason is cracks are formed through that cracks. Okay, the moisture started to penetrate, maybe water, maybe the gases penetrating the concrete surfaces. Only water will started to penetration. What will happen? It will be going to reach touch in the reinforcement. The reinforcement started to corrosion. Okay. In other cases, in other hand, what will happen? In having a cold climate, okay, minus 20 degree or 10 degrees Celsius. Okay, if having a gap when so water is penetrated, what will happen? It will be frost. Okay. Continuous freezing and dying, continuous of freezing and dying, that there is also having chances of the failure of Congress tests. So this is one of the prime method to assess the durability of the Congress using the permeability test. So it's the also a reality diagram images shows no initially be initial moisture. The above the slab, what will happen? Some of the reason the cracks will be there. Through the cracks, the water started to penetrate. Okay, because of the high pressure, what will happen? The cracks will be formation. Day by day, what will happen? The crack will be wider. So through the cracks, what will the water started to penetrate the inside. So after some time, below that, having a reinforcement, having a beam also having a reinforcement, everything started to rusted the bars. Okay, over period of the time, severe deterioration happened the entire concrete surfaces. Okay, so in the severe deterioration, very difficult to repair. Okay, so our ultimate aim when you seeing the permeable, that we need to arrest very immediately. So this is very important for the permeability for our concrete structures. So next one, the freezing and thawing test. This is only applicable for having the temperature, the minus 10 or 15 degrees Celsius. Okay. So freezing and thawing resistant, evaluate the material durability against the repeating freezing and thawing cycle commonly experienced with the cold climates. Okay. When you during the night time, what will happen? So just imagine now we started for the December. It's the month of the December. Now it's a somewhat climate is woken. When your evening time or mid of the midnight, what will happen? The winters be started. More having a mist will be there. Okay. So if you're having to see the water also be changing. During the daytime, our water is different. During the nighttime, water is a bit different. Just imagine below the 10 degree or 20 degrees Celsius, what will happen? Okay. It will be freezing and thawing and freezing, thawing continuously will be occur. Okay, so this is more applicable for the cold climate also. Just imagine our concrete member having a small cracks. Okay, what will happen? Through that cracks, water started to penetrate inside. Okay, so what will happen? Sometimes you having a cold is a climate, it will be freeze. It will be freeze. No, that water. What is the water is be entered into the through into the crack? No, it will be a freeze. Once the climate is changed, what will happen? This freezing the water started to thawing. Okay, so the cycles are repeating more than 300 or 400 times. What will happen? Freezing, thawing continuously happen. So the cracks also be started to widen. Okay, that is called the tensile crack will be occur in our concrete members. So once a tensile crack will be occur, it's having a more viable. It's having a more spaces to enter the moisture. The entire moisture will be increasing. Again, this tensile crack will be once part of the time the member started to damage, it will be severe damage and deterioration of the concrete structure. So what will we do? We having a test procedure to achieve to test the freezing thawing resistances. So moisture, we need to keep in the what you call the specimen into the 3 or 5 that one. We need to apply the minus 20 degrees Celsius for the freezing of the materials. Once we should take it out, again we need to give for thawing, it's 5 to 10 degrees Celsius plus. So continuously we need to keep for 300 to 500 degrees Celsius. Then after that we need to evaluate, we need to observe our concrete material, what is happened. Definitely it will be weight loss will be happen. That we need to measure properly. So before going to conduct the test, we need to measure properly the test. Then after that also we need to measure the weight loss test also. Then we need to find out the strength loss also. When we started to using for before that, that is called M20 concrete. Because of this repetition of the cycle, freezing and tying the cycle, definitely strength will be a loss. That strength also we need to measure properly. So visual inspection of the cracks and deterioration need to observe the properly for the freezing and tying the resistance. So we need to take on the reading visual observation for weight losses and strength losses and crack inspection. That's a dynamic crack or active crack, missing crack, okay, depth of the crack and formation of the crack, everything we can able to measure using the freezing time resistance test. This will be example, practical example, when you see the concrete surfaces, some of the reason, maybe the concrete started to having a crack. Through the crack, the water will be started to be penetrated. Water's penetration in the pores will be penetrated. Once the water started to penetrate, it will be started freezing. Because the climate is more cold, there will be water will be started to freezing. Then climate will be increasing, positive will come automatically, thawing will happen. It will continuously happen. When you started to continuously happening the freezing and thawing, definitely what will happen? Expansion will be increasing. The internal tension will be created in the concrete members. Okay, that is called because of the internal tension crack. And other surface also be created for the tension micro cracking. Okay, this will be chances to be later, the micro cracking chances to be widened. Through this widen, again the water going to start and get into the micro cracking. This micro cracking also be chances to crack will be increasing. So what will happen once the micro cracking is produced, water started to penetration, then definitely the capillary swelling will happen. Okay, the pore pressure, all the places the water can able to penetrate. Okay, it will be settled. So it will be continuous effect, freezing and thawing, because here mentioned for the minus 20 degrees Celsius for the freezing, and thawing is a plus 5 degrees Celsius. Okay, continuous freezing on the expansion cycle, definitely the deterioration will happen for the surface. So this is a test apparatus for the freezing and thawing. So this picture shows up what is happening in reality on the concrete surfaces. So what happens during the freezing? So water inside the capillary pores freeze. It will start to expand. Then expansion increase. Internal tension will be created in the concrete surfaces, create the micro cracks in the concrete. So after that also this micro crack will be converted as a macro crack. Okay, then macro crack is a meso crack will be converted. So through that also the chances of moisture penetrate into the guts. So what happened during the thawing? This height melts will be contracts. So water re-enter the pores. So it will be chances. No? When you're freezing, water can be able to penetrate. It means with thawing, it will be chances. They're giving the chances to again the water started to process. Okay. Then water will be crack with the increase in the gradually. All the entire members slowly it will started to gradually increasing. So capillary swelling causes the internal pressure. It will be effects of the concrete surface. So micro cracks grow and will be connected with all the cracks. Okay. Initially started for one micro crack, then it will be connect for all the micro cracks. So entirely the micro cracks will started to widen and allow the water more. Then again the cycle will be start freezing and thawing and freezing. The cycle will be cut. And then finally what will happen is deterioration of the entire surface. So it will be reduced totally durability and the service life of the structure. It should be really practical. It should be how the behavior of the structure for the freezing and tying is very important about concrete structure. Then very important for alkali resistance test. Normally, so evaluate the resistance of the concrete or mortar in alkaline high pH environment. That is mean greater than the 7 pH value for the high alkaline value, okay, pH value. So how we are going to conduct the test for alkaline? So concrete specimen immersed in the alkaline solution, pH value greater than the 7. Okay, 7. So answer what will happen? We need to keep it in the more days in the immerse into the alkaline solution. What will happen? It started to penetrate inside the concrete surfaces. It will start to a chemical reaction will be started. Sometimes what will happen? It will be it will go to all the places, started to the weight classes. It will go to bone in everything material for inside. Okay. So what will happen? So weight classes will be happen and strength classes will be happen. Surface damage, the crack also will be there. So we need to analyze the internal changes in the concrete. It will be chemical effect. So where we are going to this type of, so near industry area, if you construct the building, maybe chances if you're having any crack. So maybe alkaline solution, alkaline matter, maybe chances penetrate into the concrete surface. That is also we started the deterioration of the concrete surfaces. Okay, so that is also reduce the durability of the our concrete surface. That we need to measure for the alkaline reaction for that one. So based on that, we can able to conclude, we can able to select the proper mixtures, okay, to use for our concrete structure to resist the alkaline resistance of the members. So this is a laboratory test to conduct for alkaline resistance. So how the behavior of the alkaline behavior of the our concrete structure? We have here two chemical components available in the concrete surface. One is for silica, that is the reactive silica, it will be aggregate, and cement having a paste will be alkali. So here having two chemical components, one aggregate having a silica and cement paste having alkali. Okay, so the two components are available in the concrete surface. If we having any micro cracking or cracking, the moisture started to penetrate and then immediately started to the chemical reactions. So because of this chemical reaction, surrounding aggregate chances to further expansive gel formation, which is surrounding aggregate gel formation. So continuous water absorption, the gel thickness surrounding the aggregate gel thickness started to increasing like a bulb. So swelling with pressure, it's a bulb. So what will happen? The tensile crack will be occur. Internally, the expansion create the internal stresses. Okay. So cracking in the aggregate and the surrounding the concrete surfaces. Okay. Surrounding the tensile crack will be occur. So because of this, what will happen? The micro cracks, the connect and the mapping of the cracks, everything will be occur structure. So it will be chances. So it definitely be chances of deterioration of the over period of the time. So see our building structure having an example of this structure. So nearly nearly constructed for the near the chemical industry. They having a pH value of more than 7. The alkaline reaction. So because of the over maybe water or maybe air through air, that chemical started to penetrate into the concrete surfaces. Okay. So what will happen once they entered into during the moisture, it be started. We started to the deterioration of the surfaces. Okay. Next test we are going to see sulfate attack of the concrete. So evaluate the resistance of the concrete or mortar sulfate environmental. Okay. So what is the test we need to? The concrete specimen immersed in the rich sulfate rich solution. So here also we are going to check with the what is the weight losses, what is the strength losses and the surface damages. Okay. So sulfate rich loss solution SCO2 and A plus we are going to use for this type of the chemical for that one. Once if we are doing for immerse into this the surface rich solution, maybe chances for cracking, spalling and surface damage, everything is to be monitored. Properly. What will happen once you this two solution, it will creating for the aggregate the formation. Okay, the internal mineralized changes will be happen. Once internal changes will be happen, that is called for the aggregate the formation. So based on this failure, what will happen? Weight loss will be there, strength also will be reduced, surface also will be damaged. So this is a method for the sulfate attack the concrete. So how would it be? So this is a sulfate attack is happened for real life of the structure. So sulfate attack occurs when the sulfate ions react with the components in the concrete, leading to the expansion and damage. Where the sulfate is more available because the sulfate is in the soil. Okay, now in our soil having more sulfate, and groundwater also we having more surface. This will be mingled with contact with the concrete, then will be chemical reaction will be started. Okay, so that is the presence of sulfate in the soil or groundwater available. Use of the sulfate, the containing water and materials in the concrete. What will happen once the sulfate attack will happen in the concrete? There also be tensile crack will be occur. That is the expansion and the cracking also will be occur. Surface scaling and disintegration of the concrete material will be occur. So definitely final outcome is the strength will be reduced and durability of the concrete also will be reduced for the our given concrete. This is a method for the sulfate attacks. Okay, so how reaction will be happen? We discussed it. Where is sulfate available? One is a groundwater and it will be soil having groundwater. It will be with contacting with a cement matrix. Okay, matrix what will happen once it contaction what will be etignate will be, so new formation of gel will be formed. Okay. For that only what will happen? The sulfate attacks will be caused by reaction of the sulfate ions with a calcium hydroxide in the concrete. The forming the etignate, the new chemical reaction will be formed. Because of this only, our concrete members started to expand the stress. The cracks will be formed, micro cracks will be formed. That is will be damaged. That is will be final end for deterioration of the concrete. So whatever may be the things, our concrete members be impermeable. We need to maintain. So these are the tests for the durability of the concrete. So next topic for the cracks in the concrete. What we having a different type of the types and the causes of the cracks. What is the definition of the cracks? And the cracks are separation. We separate the structure into two parts. Maybe you can call it a fracture or be a discontinuity, because in earlier you're having a continuous, now it will be discontinuous, and that appear the material, it's be like a concrete or masonry, plaster. Reason is a several reason. Okay, that is maybe a physical reason or environmental reason or structural factors. Okay, and these are maybe reason. Main phenomena of the cracks will be discontinued structural member, small separation of the crack. Once the crack will be occur in our concrete surface, definitely it will affect for the durability of the concrete. Then look, appearance, the aesthetics will be changes in the concrete surfaces, and structural integrity will be changes. That is the main effect for the our cracks in the concrete surfaces. Okay, so what are the causes of concrete? We classified into three types. One is a structural crack and non-structural crack. Okay, classified into one. Structural cracks will be because of the excess of loading or overloading, which chances of the structure will be failed, and immediately foundation settlement or different movement of the settlement, maybe chances of chemical failure, and design flaws. Okay, we are not designed properly, a construction changes, whatever maybe poor detailing and inadequate reinforcement or seismic activities or the earthquake. These are will become the structural crack. So non-structural crack is the moisture movement because of the shrinkage or swelling of the concrete and changing the temperature, maybe increasing high or low, thermal expansion and contraction. That is also maybe chances of the crack. And poor workmanship, we are not using the proper quality of the material. The workmen who are all people are working in the concrete, they're not maintaining the proper quality, not doing the proper work, then also be affected for it. Cracks will be occur. So improper curing and concrete plaster. So these are the things for non-structural crack will be occur in our concrete surfaces. So based on the appearance also, we having divided different type of the cracks. One is shrinkage cracks. We shrinkage crack also divided into two. One for the plastic shrinkage crackers and drain shrinkage crackers. So plastic shrinkage cracker appear rapid loss the fresh concrete. Once pouring the concrete, immediately water started to evaporate. No? Then immediately because of the water evaporation, crack will become. That type of the crack will be called for the plastic shrinkage crack. So what is a dry shrinkage crack? Occurs when the concrete or mortar loses the moisture and contact the over period. It won't show the immediate cracks. It should take for light time cracks. So after hardening of the concrete, then it will get for some of the crack that is called dry shrinkage crack. Okay. So because of the foundation failure, the movement of the soil or settlement of the uneven leading, maybe chances of vertical crack or maybe chances are horizontal cracks, maybe in the wall or floors or roofs or whatever maybe, that is set, that is cracked for the settlement of the crack, mainly for the foundation failure will come. Okay, that's correct. Okay. On thermal cracks caused by the temperature, maybe the variation and leading to the expansion and the contraction of the material, the thermal cracks will come because of the currently when reinforcement bar rust. Okay, because somehow the moisture can able to enter in the concrete surfaces, maybe rust in the reinforcement. Though maybe that because of rust, the expansion will come. Maybe chances of causes of the cracking. So maybe I found the long concrete. The masonry structure where no expansion joints are provided, maybe during the summer season the chances to be expand, then during the winter it will be contraction. If not provide the construction joint properly, what will happen? The members started to expand. If not provided, automatically crack will be start. So somehow it will be earthquake cracks also due to the seismic forces causing the shear and bending and torsional structure in the structure, maybe chances to failure. The overall structure also be chances to. So these are the cracks, based on the appearance we can able to classify. What is in the effect of the climate and temperature of the concrete? What is the causes of the reason for this one? Exposure, changing climate in condition, frequently changing of the causes will be happening with temperature. So daily seasonal variation, daytime one temperature and evening to one temperature because of that one, maybe the causes. Then cold and hot climate cycle will be changes. Then long duration elevated temperature because of structure, more temperature, elevated temperature, our structures exposure because of the industrial fire or industrial heat, our structure may be sustained. There are also chances to failure of the concrete surfaces. The continuous freezing cycle in the cold region may be the chances. So what will happen in the concrete member? Definitely these are reason thermal expansion and contraction will be happen. For that also maybe failure will happen in the concrete structure. So in the temperature increasing as temperature decreasing, shrinkage crack will be occur. Then increasing the permeability due to the micro crack. Essentially crack will form micro crack. Then moisture will be entered automatically started for increasing crack, then increasing the permeability too. Then accelerated corrosion of the reinforcement is giving the chances to reinforcement rebar. Will be corrosion will be there. And then definitely losses will happen bond between the steel and concrete in the concrete. So how it will be affect in the durability? Reduce the service life. Okay, when we are assumed for 50 years and be 60 or 70 years, no, that automatically to reduce. Okay, one is the concrete started to fail. So increasing the maintenance, of course, if a repair deterioration will happen, we need to do proper repairing method to maintain our building. Definitely increasing our material cost also. So automatically our structure will be weak performance of the structure. So how to prevent this type of the cracks and control measure? To provide the proper, as per IS code, what they're mentioning, we need to provide the proper expansion and contraction time. Use the temperature resistance of material. So now field having different type of the materials available to resist the temperature. Those type of the material we need to select, we need to incorporate in our construction. So faster deterioration under the aggressive the environmental measures. So these are the prevention control measures we can able to take care to for a climate and temperature of the concrete to reduce for that one. Okay, so this is a mind map. What we have discussed in the last couple of this slide. So durability and serviceability of the concrete. First, we have discussed about the quality assurance. Once if you want to maintain the quality assurance, we need to select the proper materials, high quality of the materials. There we have discussed about the 3 stages: pre-construction stages, during construction stages, and post-construction stages. That means the mix design, collection of the material, proper mixing, proper curing, and proper testing. Based on that, we can able to achieve the quality assurance of the concrete. Then we discussed about the strength and durability of the concrete. Okay, in the strength point of view, what we did were compressive strength, flexural strength, and the split tensile strength we have discussed. When talking about the durability, we have discussed about the abrasion resistance and chemical resistance, permeability and chloride test. That and all we discussed about the durability test. Next, cracks in the concrete. What is the 2 type of cracks: structural cracks, non-structural cracks, and cracks we classified into appearance. Okay, causes the cracking. That is how to prevent method for the cracking. What we discussed. Okay, then effect of the climate and temperature. Now we completed for the freezing of time cycles. Because of that, how the structure behavior, then thermal expansion, hot weather condition, humid condition, how our concrete members have to behave. So this is called for milestone to understanding what is that in module 2 discuss serviceability and durability of the concrete structures. Okay, hope learners you can understand the concept of the serviceability and durability of the concrete structure based on the what we have discussed in the classes. Then hope understand the learners quality assurance measure and achieving the strength and the durability of the concrete, and understand the different type of the cracks in the concrete and their causes, how to remedy of the blockage of cracks also we have discussed. Okay, then learners can understand the effect of the climate and temperature of the concrete, what will happen over performance of the structure, when of the strength and the durability point of view. Hope all the learners can understand the lecture what we delivered for module 2. Okay, so these are the reference for our topic. So one is for the Dong Vincent, it will be abroad. He's a very good person, both for academic as well as research point of view, who are in the need for practical application. Okay, practical application who are going to serve into the field. We can able to refer the concrete structure protection, repair and rehabilitation of the structures. This type of the reference book, and this will be a concrete structure repair and rehabilitation of the retrofitting Bhattacharya is an IIT professor. We can able to use for the practical application as well as the undergraduate and postgraduate. The students can usually understand what is a practical application, because the professor is a main dealing with both the consultancy job as well as the professor in associating the IITs. Okay, so they are having a detail, more case studies, what they are observed, everything given in the detail. So, Professor J. Nandini Devi, the maintenance, repair, and rehabilitation retrofitting of the structure is exclusively for the maintenance and repair rehabilitation structure for the structures. Okay, these are the discussed in the reference for the textbook for in our subjects. Okay, so hope the learners you can understand the serviceability and durability of the concrete structure that we are discussing in the module 2. So very soon we are going to discuss about the one more session, module 3. We are going to discuss very soon. So thank you all once again. We are going to meet very soon. Thank you very much all.